Setting it up. All right, we are officially live. Hello, everyone. We are getting ready for Science of Star Wars. So if you're just joining us, we're gonna wait for a couple of minutes for some people to get on, and then we will get started here for the Science of Star Wars with Dr. Chelsea Harris. We're excited for you guys to be here today. All right. Hooray. We're gonna get started here in just a couple of minutes. We're gonna probably wait until about a minute after 7 o'clock or so we can let everyone join. We have quite a few people joining again. So if you are joining, please let us know in the comments that you are here. Say hi. Tell us what your favorite Star Wars movie is. Maybe that'll start a controversy. Maybe that's not a good thing. I don't know. I will tell you, if you can't tell already by what I'm wearing, mine is Return of the Jedi. Kirsten Thompson said, excited. We're excited too. Thanks for joining us. Did anyone else dress up? I know we can't see you, but is anyone else dressed up? If you are, please post a picture if you're willing. We'd love to see your costumes.
I want to see costumes.
Someone said episode 1 is their favorite. Just kidding.
Yeah, because we can't kick people off Facebook Live, right?
Oh, Mary said she loves all the Star Wars movies. May the 4th be with you too, Margaret Ackerman. Oh, someone said Revenge of the Sith. Oh, the Force is strong with me, said Jane. Thank you, Jane. I appreciate that. Hi, Sam and Luke. Thanks for joining us. All right. Well, I think we can go ahead and get started. It is just after 7 now. This video will be archived, so if anyone is going to be joining us later on, if you come in after we've gotten started, it will be archived under the videos for Abrams Planetarium, so you can always go back and watch. But we are going to go ahead. I'm looking at 2 different screens, so if you see me looking off in weird ways, I apologize. But I'm very excited to have everyone here for the Science of Star Wars on May the 4th. May the 4th be with you, with everyone. I'm very excited. We have Dr. Chelsea Harris here with us, who's going to be talking about the science and the astronomy specifically of Star Wars. And she was supposed to do the Astronomical Horizons lecture at Abrams Planetarium in March, but it was scheduled right after we had to close due to COVID-19. And so we're going to be saving, and she was going to talk about the science of science fiction. And we're going to save that particular talk for later because we had a lot of really wonderful things for the Planetarium Dome to show everybody. So we'll reschedule that for the future. But we decided that we'd still do something really wonderful and great for the Science of Star Wars today on May the 4th, which is, of course, Star Wars Day. So I'm going to go head off into the corner here and give it up for Dr. Chelsea Harris.
All right. I'm going to now do the dangerous mission of trying to share my screen. Host disabled attendees sharing. We practiced this, but we still forgot.
I did not. There we go. You can do it now.
Okay. All right, I'm gonna do this. Okay, share computer sound. There will be videos with sound for this presentation. So just after the first one, you might get surprised by your volume and have to adjust. All right, so let's get to it. Thank you so much for joining me for May the 4th. Definitely trying to end by 8 so that we can still watch a Star Wars movie tonight and get to bed for a work night. So basically this talk, we're just going to be looking at different astronomical, formulae and principles that come in when you're watching Star Wars. And even though Star Wars is space fantasy, it's not science fiction. It's such a visual story that it really can set your intuition for what space looks like. And it can do that for better or for worse. And so I'm going to be talking about some of the things that it gets right and wrong throughout the series, primarily focusing on the original trilogy and the newer trilogy. The first thing is, for me, is about any story set in space is space travel. This is one of the things that got me into astronomy. I almost pursued a degree in aerospace engineering, actually, to build rockets and things, because it's such a crazy concept that space is just so big. How could we ever be ourselves in one of these stories? And one of the big problems is that you have this cosmic speed limit of the speed of light, which is 670 million miles per hour. So that's a lot. And, we're limited by the speed of light in our everyday lives, but we still think of text messages and things as instant. And so we don't really notice the speed of light in our everyday lives. But the thing is, space is really big. And that is the thing that I think is really hard to appreciate unless you think a lot about it. So like the Milky Way galaxy can be measured in light years. That's a unit of distance that we sometimes use to talk about space. And it's 100,000 light years wide, approximately. And that unit of measurement literally means that the fastest thing in the entire universe takes 100,000 years for light to go from one end to the other of our galaxy. So space is just really big. It's even big on the scale of our solar system, even if you're not thinking about the entire galaxy. Like a snail can cross a sidewalk faster than light can get from Earth to Mars, which is like one of the closest planets to us. I mean, depending on where it is in its orbit, obviously. So the speed of light is the speed limit, and yet in the context of space and space travel, you still have these really long times to get anywhere of interest. And so a lot of science fiction, the first thing that you have to get across is, how are you going to solve this speed limit problem? It's really common for people to just fall asleep. So basically any space voyage would be really actually boring, and maybe you just want to sleep through it. And so you see a lot of representations of stasis. And, Star Trek got it right. We would obviously be wearing gold underwear. So kudos to them. But my issue with stasis is that inevitably, someone goes insane. So this path will always end in everyone dying. So we should not ever do this. Another option that we have for getting around the speed of light is to just alter space-time somehow. So in Star Trek, they have the warp drive, which literally sets up a field that warps space-time so that in your reference frame, you're still going slower than the speed of light, but in the external reference frame, you're going faster than the speed of light. And then there is this common thing called a wormhole, where you would kind of fold space-time and just go between 2 points. And both of these are theoretically not valid, but I will say that they both appeared as problems in my general relativity textbook when I took the class. So these are things that we have actually looked into and explored, and they're not viable, but they're invoked a lot in sci-fi. What Star Wars does is different from all these things. It invokes something called hyperspace. And hyperspace is something that basically is like a different dimension. And in this different dimension, which contains our normal 4-dimensional space-time, the speed of light is faster. And so what that means is that as long as you can access this dimension, now you can go faster than the speed of light. and then re-enter in normal space-time at a much farther location. So the Millennium Falcon would, pop into hyperspace and then pop back where it needs to go. And it's really important if you're using hyperspace that when you come out of hyperspace, you're pretty much exactly where you want to be, because as soon as you're back in normal space, everything's really far apart and you are a snail and you can't get anywhere. And so you better be where you need to be already. So usually in Star Wars, we have these really cool visuals where you come out of hyperspace and you have this immediate confrontation, like here from Rogue One, right? So all these allied, the good guys are, facing the Star Destroyer there right away. And I think that they must have some sort of like networking thing, because in general, it would be super dangerous to pop out of space this close to your allies. You'd be like colliding and stuff. So they must, network the calculations or something. But if you're not in hyperspace, you are really not going anywhere. Now we're going to watch a scene where they just decided to completely ignore that. So in the Escape from Jakku from The Force Awakens, I'm going to show you two little clips. And the first is when Finn and Rey first get the Millennium Falcon. Its hyperdrive is off. They fly out of Jakku, and the next time we see them, they're picked up by Han Solo and Chewbacca. This scene is so insane, because if you know the astronomy, like, they don't have hyperdrive. So how far can they really get?
Where'd you get this ship?
Name outpost.
Jakku?
So if you're on Mars, then this is the way that Earth looks in your sky. And it's just like a little point, right? So it looks like you're really far away. It takes 4 minutes to get to Mars at the speed of light. And so in the Millennium Falcon, it would take even longer than that just to get to Mars, and you'd still be in the same solar system. So basically, there's essentially no way without hyperdrive that you're getting out of the solar system. And without hyperdrive, with most propulsion methods, you're still in the solar system. And so if they knew the speed of light and the astronomy, the way that scene would have gone is, they would have met Han and Chewie, and Han Chewie would have been like, "Where'd you get that ship from?" And Rey and Finn would have been like, "Jakku," and Han would be like, looks out the window, "Oh, that planet that we're still in orbit of. Okay, yeah, cool, that makes sense." So they would still be super close, and that scene makes no sense. The other way of kind of propulsion, and the other famous ships in the Star Wars series, are these TIE fighters. And this also relates to some actual real propulsion mechanisms that we have on Earth. So the actual reason that they're called TIE fighters is because they look like a bow tie. But then later, people made stuff up and decided that the tiny lights that are on these TIE fighters were twin ion engines. And ion engines are real technology that we have. And the basic concept behind an ion engine is very nicely illustrated in this clip from WALL-E. So you literally just shoot stuff out to propel yourself in the opposite direction. It's really the same thing. So this is an image of an actual ion engine being tested, except what it's firing out is ions and electrons, but the ions are the heavy things that are propelling you forward. And ions are really light. So this is a low impulse engine, but it's a really high propulsion efficiency. So if this was your car, you'd be getting 250 miles per gallon, which is a metric that is much more resonant with people when we're driving places, not when we're on lockdown. But still, I mean, that'd be pretty great, right? So this is something that's good if you have a voyage that would benefit from a really long and slow acceleration to get you to your speed. So it's good for long voyages, not so good for the tight maneuvering that TIE fighters do. But we have an actual mission that uses ion engines called Dawn, and here it is unfolded. So that kind of looks like a TIE fighter, I guess. It has a circle. And Dawn went and explored the asteroid belt. So this is its sort of flight path here. And you can see that it took 4 years basically to get to one of its first major targets, and its whole journey was like 7 years. But it came back and gave us this, like, I mean, a lot of data, but one of the data series that it gave us is this beautiful image of Ceres. So talking about dawn is a really good time to talk about asteroids. That's something else that comes up in Star Wars as like a major plot point, like all the time. So the first time is in The Empire Strikes Back, you know, when they have to like hide in this asteroid field and like avoid the Empire. And C-3PO is like, oh, you're never gonna make that, basically. And the idea that an asteroid field looks like this, I think, is motivated by plots like this. So our actual knowledge of the asteroid belt, if we put a dot everywhere that we kind of know an asteroid is, it would look like this, which looks really crowded. But it only looks crowded because it's not to scale. Those dots don't represent the size of the asteroids compared to the scale of the orbits. So all the orbital distances are to scale, but then the dots are too large. So it looks like they're really clustered, but in reality, their average separation is like 10 times the distance between the Earth and the Moon. So it's pretty large, especially given that these are objects that are like smaller than the Moon, right? So what happens, and they're also far away from the sun, so they're not reflecting a lot. And so if you're standing on most asteroids, you couldn't even see another one. It wouldn't look anything like, you know, it's represented in movies and video games. And yet it is represented this way all the time. Like it just keeps being shown like asteroid fields are super dense. And based on this last image in Revenge of the Sith, I have this hypothesis that Yoda here is actually using the Force to like make all these asteroids be so close, because otherwise this is just physically not how, you know, the universe would be working. All right, so any questions about that portion on distances? Oh, Shannon, I can't hear you for some reason.
There we go. So if anyone has any questions, you can put them in the comments. We did forget to mention this at the top, but if you have any questions, put them in the comments. We'll kind of have spots like this throughout. We do have a bit of a 20-second delay between what we have on Zoom versus what we see on there. So we might have a bit here, but there's going to be more to the talk after this, so don't leave. Oh, we do have one question. Would the asteroids have a gravitational pull that would hurt the ship?
So asteroids do have a gravitational pull. That is something that people study, especially when they're studying like planet formation, is kind of like how they tug on each other and how do things kind of coalesce. But that gravitational field would not be able to like pull in a spaceship. Actually, it's really hard when we think about mining asteroids. This is something that we have to think a lot about, because the miners like trying to mine into the asteroid like push themselves up because the asteroid can't keep them down.
Awesome, thank you. Is there, could you land the Millennium Falcon on an asteroid? That is from Susan K. And then Ronnie asked the first question there about that you just answered. So Susan asked, could you land the Millennium Falcon on an asteroid?
Landing anything on an asteroid is difficult, but obviously a pilot of Han Solo's, you know, caliber could do it.
Merida asked, is there one with Yoda in it?
Is there an asteroid with Yoda in it?
Yeah, with Yoda.
We can't prove there isn't. A famous scientist once said that anything that's not disallowed by nature like must exist or something. So I'm gonna say yes.
Kathy asked, how does the Force work?
Well, it permeates all living things that binds us.
And then Jane asked, isn't Star Wars set in a different galaxy though, one that's far, far away, and maybe their asteroid belts might be different?
Yeah, so I don't know if I should go down the philosophical wormhole of like how do we know physics is the same like everywhere in space. That's something that we just say is like a principle. But basically, it's because if asteroids were this close together, then that gravitational pull that was mentioned earlier, that would come into play a lot more because gravity has a stronger pull the closer you are. And so that's essentially how planets form. So basically, what I'm saying is you wouldn't maintain an asteroid field; you would coalesce that into planets. And so, like, yeah, maybe if they're like maybe if like two rocks were like about to collide and you decided to fly into them, like you'd find a field that dense.
Cindy asked, would our moon be considered an asteroid?
No, I don't think it is. I think the asteroids, because I think that like the moon was formed from like a collision with the Earth, and then it like the Earth got pulled apart. Whereas like asteroids are were like never part of planets. They're like the original like planetary debris disk still.
Are there any examples in Star Wars of the Force traveling faster than light?
You know they are. Whoever asked that. Yeah, it's like
Nat.
Matt or Pat?
Nat.
Nat, yeah. Nat is obviously trolling because yeah, that original Star Wars, it's like, okay, I guess the Force just does whatever.
Okay. Susie asked, is it possible that the asteroids are destroyed planets?
Ooh, I like that. So I think that that kind of thing can happen. You can tidally disrupt a planet and you can make a transient asteroid field, but you can only really do that like really super close to the star. So I'm not really sure that that like would line up with the rest, and it definitely wouldn't. It'd be really weird for that to be like a ubiquitous thing, you know, where you're like finding that like all over the place in every single planet system or whatever. That's an interesting question, though.
All right. Is hyperspace possible in real life? From Laura Ann.
I think so. But I am going to go full Mulder on this one. I want to believe.
I approve of X-Files references. Scully is the reason why I'm a scientist. Would time be consistent in hyperspace, from Ronnie? Would time be consistent in hyperspace, or would people going towards you be relatively older or younger than you?
I have not looked into the hyperspace math in enough detail to answer that question. That's the kind of question that they would like pose in like a hyperspace textbook to solve.
Okay. And did Susan asked, did an asteroid kill the dinosaurs?
I don't actually, Shannon, you might know this better than I do. I don't think that they think that originated in the asteroid belt, do they?
Well, I think the understanding is that some sort of asteroid did hit the Earth, but it wasn't that the asteroid hit the Earth and then that's what killed it necessarily, but it did likely cause something within the atmosphere that then burned the atmosphere that then killed the dinosaurs.
Okay, but the object originated in the asteroid belt, not like in the Kuiper belt or something like that.
Yeah, I'm not entirely sure. It would likely be from the asteroid belt. I think Kuiper belt objects tend not to come to Earth, but I'm not 100% on that. All right. And then last question before we move on, Penelope wants to would like to know, is our second moon considered an asteroid? There's some thought that we have maybe a second moon.
So I don't think that some of this is, I think, a little bit of like nomenclature stuff. Like I don't even think, like technically, like I don't even think an asteroid could hit the Earth because then it becomes like a meteor or a meteorite or something. Like but no, I don't think that we would consider that an asteroid either.
Yes, some moons around planets are like considered captured asteroids. So I don't know enough about this possible second moon, but
Yeah.
Yeah, like
That kind
Mars
of comes
and
down
Venus
to,
are captured asteroids.
yeah, that would come down to like a nomenclature issue though, more than like a physical thing.
Yeah. All right, shall we move on?
Yes.
If you have more questions, pop them into the comments and we'll keep checking them as we go on, and we'll stop for more questions throughout.
Yes.
So there's more sections though, so we'll keep going.
Okay. So this next section, okay, I'm just going to be really upfront about this. The Force Awakens had some things that just didn't sit well with me at all and still upset me like to this day. The next section is going to be an example of teachable moments from The Force Awakens just from one scene. So this is the scene where we are watching the destruction of the Hosnian system from Takodana until The Last Jedi, but now I do, thank God. Every word of that scene is wrong. And I'm just going to go through like the three principal things that are just like so fundamental that are wrong in the visuals of that. And it pretty much comes down mostly to the fact that they incorporated Takodana at all. Okay, so one issue is that they released an official map of the Star Wars galaxy. So this is officially fact. And if the Star Wars galaxy is a Milky Way like thing, and Milky Way is pretty typical, so it's not going to be, you know, much smaller than this or anything, then these two planet systems, Takodana, where Han was, and Hosnian Prime that got destroyed, are 40,000 light years apart, approximately. Okay. Well, so you can see that Hosnian system, 40,000 light years away, it spread out over the Takodana sky. And so I just kind of traced like those rays so that you can see it more clearly. But if we kind of say like, you know, how does the moon look in our sky, then we can get an estimate of like what this spread is. And in astronomy, we measure this in angles, kind of like latitude and longitude because of the sphere. So that spread is approximately 40 arc minutes. And the issue with this is that when things are physically separated by a fixed amount, like railroad tracks or the bars in the letter E, as they get farther away and like appear smaller, the parallel lines tend to converge. So this is something that you know from like art. I mean, this is actually something I had to discover in art, but still, this is a mathematical like thing, right? So as you go to infinity, they converge to a point. We know this from our exams. So things appear closer together, the farther away they are, the same physical separation. And this is something that's used a lot in astronomy, actually. So if you're interested in cosmology, you might want to look up like standard rulers. So this is called an angular distance, and we use this all the time. And so if you look at the Hosnian prime system, maybe these planets are separated by like 5 astronomical units, which is the distance between the Earth and the Sun, something like that. So then the angular extent that they'd have at Takodana is something that you can calculate because we know the distance away. And it is like 7 millionths of an arc minute. The limit of the human eye's resolution, so ability to like distinguish lines that are separated, is 1 arc minute. So 1,000,000 times more than this. And the angular separation that you see in the scene is 40 arc minutes. So literally this scene is 1,000,000,000% wrong. This is just totally wild to me that they represented it this way. The other thing is that this is 40,000 light years away. As things get farther away from you, they get dimmer. That's another really important astronomical principle. That is the thing that, that's how we can use standard candles in cosmology. Like for type 1a supernovae, getting the Nobel Prize discovering dark energy, it's all about this principle that farther away things look dimmer or are dimmer. So the limit that a human on Takodana could see would be like this small orange circle, like very, like not far at all can you see into space. Even the Kepler Space Telescope can only see, let me see if I can go back to that. Okay, I can't. Can only see out to 3,000 light years. So it would be too dim to even see in the sky. And then the last thing that's just so fundamental is that if this thing is 40,000 light years away, It literally takes light 40,000 years to get from Hosnian Prime, the light like of the beams destroying the planets. It would take 40,000 years for those photons to go from Hosnian Prime to Takodana. And when they did, they'd be too dim to see it, so no one cares. But still, 40,000 years later, would Han be looking in the sky being like, oh, I guess something happened, right? And even then, I already argued that he wouldn't see what he saw. So basically, these are my bros in this scene, the people who like are not looking up in the sky, who are just like, nothing's happening, because nothing would be happening. This is why in the first movie, you need the Force to, okay, they didn't actually need the Force because then, you know, they went and saw that the planet was destroyed or whatever. But still, like if you want to communicate a message faster than the speed of light, you would need something like the Force so you could be like, oh my God, everyone just died immediately, because you wouldn't be able to see something in the sky like this. So these are my bros, Yellow Arrow. Shout out to those guys. I hope that their acting careers are going well because they're my favorites. And basically this all amounts to the fact that the writers don't understand the difference between a solar system and a galaxy. Everything that they did here, all the visual representations, make a lot more sense if the Hosnian Prime system was the same solar system as Takodana, and it's just not. So like they don't get this. I don't think J.J. Abrams knows astronomy like at all. Maybe he does now, but definitely not when he wrote this. And it's something that in the original trilogy, they did really well, because what they did was they just used intuition from being on this planet. So like, you know, Death Star, approximately the size of the moon. Well, you know how the moon looks in the sky. So you kind of know how the Death Star should look in the sky here. And so that's a big difference. So if you're writing science fiction screenplays or whatever, my advice is to get your characters onto a planet as fast as possible and then just like make things similar to Earth, because otherwise you might go wrong with stuff like this unless you calculate it out. Oops. All right, this is another break for questions.
All right, are there any questions about this section before we move on to the next? Could hyperspace fumes or something like that be making photons go farther faster from Susie?
You have to have like a machine to like get something into hyperspace and then out. Like even though hyperspace like exists passively, you still have to like do something to get them there, which is another issue with those beams, but whatever. So I don't see a way for photons to like accidentally enter hyperspace.
Merida asks, what are asteroids?
Rocks. I mean, honestly, it's just like leftover crap. Like, honestly, like that's almost what the planets are. It's like the universe was trying to make a star and there was just like leftover stuff. And then we tried to gravitationally collapse to planets, and Jupiter is just messing everything up. So you know, everything started at like a really small scale and then had to like coagulate through gravity into the planetary bodies. So what asteroids are, you know, they're held together partly by gravity, partly by electromagnetic forces. And they just can't become anything else. There's too much of competing gravitational stresses from the other like planets and stuff. So they're just kind of losers, like planetary losers, I guess.
All right. One question is, why do all aliens speak English? And is gravity different on the Star Wars planets? From Jennifer.
In Star Wars, not all aliens speak English, so that's awesome. And then in like Star Trek, they have to have universal translators and stuff. One of my favorite things is in Farscape, where they don't use like minutes and seconds, but they have like arns for hours. Okay, this might just be Australian. I honestly don't know, but they say like arns instead of hours and microts instead of seconds, and that's awesome.
Farscape is one of my favorite shows of all time, and everyone should go watch it.
Yes, if you like aliens, it has so many aliens. Yeah, we really like it a lot.
And there are puppets. So if you love Yoda, like some of the best characters are from Jim Henson's Creature
Yes.
Shop. Okay.
Yeah, it's really good. And then the other question, the second part of that question,
is gravity different on Star Wars planets?
so gravity ought to be different, but it almost never is in movie representations of planets. And that is wild. I mean, yeah, like Venus's gravity is almost the same as Earth's, but presumably that shouldn't be happening so often. And like, how do the ships have gravity? Like, big gravity is like such a big plot hole.
I feel like they have limitations though on the planet they have to film on.
They do, yeah. They can't. We wouldn't want everyone to be Stanley Kubrick. He was like abusive.
Does it smell in space from Susan?
I don't think that the particles are dense enough. I mean, you mean the presumably like not on a planet in space, like if you were in the interstellar medium or something. I don't think that the planets or that the gas is like dense enough for us to like register it as a smell. But it's funny because my PhD advisor asked the same thing. He's like, why do we care so much about how things look? Why don't we care more about how they smell? And I was like, really?
Jane asks, have you considered considered writing to Disney to offer your consulting services?
Ooh, I considered applying to Disney for something like that, but instead I continued to be successful in academia, so that just ruined that dream.
Ginny asked, is there a laser in existence that could shoot within a solar system from a planet to a moon or a planet to planet?
Oh, well, they're trying to build something kind of like that for the Star Shot. So like they talk about doing something like, but it wouldn't be like an optical laser, but I don't think anything like that exists right now, no.
Okay. Susan asks, does time travel exist?
I am traveling through time right now, forward, and very slowly.
Laura Ann asks, is the Death Star a possibility?
A possibility?
Yeah, is the Death Star a possibility?
Yeah, so one of the main, so I kind of think about like building spaceships a lot. Like it's not an active area of research, but seriously, one of the main issues about building something of that size is we don't have anything like a space elevator to efficiently transport things from the Earth's surface like up to build something that is a true like space ship. And then also it's, you know, it's supposed to be the size of a small moon. So we'd probably want to be like mining like other bodies. So we'd have to figure something like that out. But other than that, I think that the structure, like just having a sphere that big with like residences in it, like I feel like that isn't technically impossible. I mean, the Death Star can like go into hyperspace and stuff, so that's like a whole other can of worms. So I think not in detail, but in broader aspects, yes, in the distant future.
All right, with such distances, is there any way you could imagine technology to see further faster, like laser positioning from Matthew?
Further, faster. So you'll be, I don't know that I quite know what the faster means there. So like we do the like laser guide star type thing to get better resolution on our images. But that's basically an instrument calibration technique. Because what we're seeing is, well, okay, it doesn't matter if we're looking at photons, neutrinos, or gravitational waves. They're all limited by the speed of light. So if we see something further, it's necessarily going to be like older. The light travel time will be longer. We can always like try to increase the sensitivity of our instruments. How you do that depends on the instrument, so that you can see further. But I guess like we could see further faster if the government gave us more money, please.
All right, and last question for this section is a bit off topic, but could asteroids destroy the International Space Station like in the movie Gravity?
Ooh, okay, so I haven't seen Gravity, so I don't know exactly what they invoke, but because I've heard about it, I assume it's stupid and cannot happen. I'm just kidding, but so things like actually, so asteroids are like really big. In general, there are more little things than there are big things. And in space, like even the little things can be traveling so fast that they become a problem. So like little like micro like dust type things, if it's traveling fast enough, can be an issue that can mess up your spacecraft. I don't know exactly what type of technology they have on the ISS for if somehow an asteroid was on like a direct collision course, which is incredibly unlikely. I don't know exactly what its thruster configuration is to get it out of the way of that. But like technically, like if you could get the asteroid into position, then sure, yeah, it could take out the ISS, it could take out the Earth, like life on Earth, you know, but you probably couldn't get it there.
All right, let's move on. And if you do have more questions, keep putting them in the chat and we'll take a look at them. But we'll move on for now. Okay. We do want to give you time to watch Star Wars movies.
Yes. Yeah, so we might not get to the last section. This might end up being the final section we can get to. We'll see. Okay. Meanwhile, on Alderaan. This image always cracks me up. I don't know why. Okay, so let's talk about lasers. So we're all obsessed with how asteroids can mess stuff up, but let's talk about lasers messing things up. This kind of goes into like, how do you destroy a thing that's gravitationally bound? All right, so the Death Star can destroy a planet. How do you do that? So anything that is gravitationally bound means that gravity really wants that thing to like stay in place and stay put, and is pulling it toward the center. And the way that we characterize that is by a gravitational binding energy. So for the Earth, so I gave you the formula here, and for the Earth, it's like 10 to the 32 joules, which is like 10 to the 30 light bulbs shining for a single second. So it's this unimaginable amount of energy. That would be 1 billion times more energy than in all the fossil fuel on Earth. So like if you ignited, you know, all the fossil fuel on Earth, you still wouldn't completely destroy the Earth. In fact, we think that the moon probably happened from something colliding with the Earth and ripping off a chunk. Like it didn't destroy the Earth, it just was able to rip off a chunk, because it's really hard to destroy a planet. In a different sense, you would destroy the planet if you ignited all the fossil fuel on Earth, but you know, we're already on that one. So in the Death Star, you have 9 beams, which means that it's like 1/10 of the total output. So 10 to the 31 joules each, which is like the daily output energy of the sun in this beam, right? Which makes these guys like the dumbest workers in the entire universe, that they would take this job. They must be in trouble or something and just didn't get force choked. Something that I really liked in The Last Jedi was that they introduced this technology of like a mini Death Star that could be a battering ram. So this is it when it's just being dragged into position, and then this is it when it's on, and like never mind the hero dying in the foreground. But the thing that I really liked about the way that they did this scene was that they show how if you're hitting something with this much energy, like yeah, it's a lot of energy, but it still takes time to actually like inject that energy into a material to deteriorate it. So I like that about this scene. And so then there's a question of like, if you wanted something like Starkiller Base, like how would you power that? You know, where do you get the energy to destroy 5 planets? That would be like 3.5 times 10 to the 33 joules, right? 5 times the Death Star. And the way that they do it is they rip it from a star. So let's watch this scene. So that's how they're getting their power that they'll ultimately use to destroy planets. The thing is that you're taking the mass from a star, and they in this scene in particular are stealing like all the mass from the star, and then they're compressing it down to the size of a planet. Someone asked about gravity earlier. this would increase the surface gravity of this planet by a factor of 300,000 because you're just shoving more mass in and shoving more gravitational pull in. And like, you know, everyone on the planet would just get squashed into like pancakes, and instead they're having like lightsaber battles that are like beautiful and epic or whatever. But the other thing that's really cool about this scene, even though it's totally wrong and in some ways I really hate it, is that they're showing this like object, the star killer base, pulling matter into from a star. And I don't know exactly how Star Killer Base is supposed to be doing this. It looks like it's funneling it with its own field. But in nature, this type of thing really does happen. And it can be as sharp as this. Like when with the, if you flow through a Roche lobe, it can be this really sharp funnel onto another star. So this would be kind of like an interacting binary star system, which I really love. That's the type that probably make a lot of type 1b supernovae, and it's definitely what makes type 1a supernovae, which are my favorite. So this scene was pretty cool, except for the fact that it was like totally wrong for like Star Killer Base. And then actually when you see something that's like a type 1a supernovae at the end when the Star Killer Base is destroyed. So the planet gets destroyed, and then there's this like star just sitting there. So what you have then is something that's the mass of a star, but it's the size of the Earth. And this is something that actually exists. These are white dwarf stars, and they're literally supported by quantum mechanics. It's the Pauli exclusion principle for fermions, electrons. So this type of object could really exist. And it's these types of white dwarfs are what create type 1a supernovae. So if you keep adding matter onto it, eventually it becomes unstable and it can explode. The other thing that can happen so Star Killer Base kept pulling matter. If it got above like 1.4 solar masses of matter that it had pulled in, it would just collapse into a neutron star. Good luck tapping energy from that. And then if you got above, I think it's like, for a neutron star, it's like they don't actually know for sure, but I think it's like two or three solar masses for a neutron star to become a black hole. So making compact objects like this is something that can happen in real life. It doesn't usually happen by blowing up a planet though. Okay, so speaking of another cool like extension to the Death Star concept that they did in Rogue One was to say that the Death Star could be in like a low power mode where you just destroy like a city. And there was this really pretty image where they destroyed Jeddah, right? Or this holy city on Jeddah. And that image of the city being destroyed, and this is on a moon, so it should have lower gravity, and all this stuff is coming up. That's sort of like the eruptions that we see on tectonically or volcanically active like moons. Like this is of Enceladus right here. And you can see this eruption in the left-hand panel. And then you can even see it like making an impact there in a ring, in the E-ring there around Saturn. So that eruption is actually really cool in how it seems so motivated by astronomical images, just the shape of it and kind of these like plumes and stuff. I like this a lot. There are also really cool videos or images that you can see of volcanic activity like on Io. Okay, here's another stopping place for questions. There is one section after this if we have time, just so you guys know.
All right, so there are a couple of questions that have popped up. So one is, when was the last time an asteroid struck the moon? From Cindy.
I do not know the answer to that. I don't even know if that should be somewhat well constrained from like the magma inflows. Do you know that at all, Shannon?
I mean, technically, it's probably being hit constantly, just like the Earth is. I mean, we have daily meteorite hits on Earth, and so the moon would likely as well. But the last major time would have been during like heavy bombardment, which would have been, when was that? how many billions of years ago was late heavy bombardment? A couple billion years ago.
Like we haven't seen anything like that in human looking at sky history.
Yeah, I mean the thing is there's always little rocks that are floating around. If you want to learn more about meteorites and sort of like when they're hitting things for both Earth, and it would be fairly similar for the moon. Abrams is running a sort of a weekly series at 10 a.m. on Wednesdays, and you can always go back and rewatch the videos with our meteorite collections coordinator, Craig Whitford, and we're opening a meteorite exhibit hopefully when this is all done. So come and check that out. We'll have our whole collection on display, hopefully in the fall. Might be delayed a bit after all of this, but you can go check out Craig's videos. They're on Facebook and our YouTube channel, and you can go learn all about meteors. And we also have one on lunar meteorites where something did hit the moon and then knocked a chunk off, and then that fell to Earth, and now we have pieces of moon rock that way. So that would be a great way to learn more about that. And then another question, we also have something from Amy about all of your comments on the lasers. So many OSHA violations, definitely.
Would the Empire really have OSHA?
No.
They're evil.
Michael asked, could a defensive shield be created by emitting a strong enough electromagnetic force to repel any lasers or asteroids?
Oh, yeah. So let's see. So for interrupting a laser, let's see. So lasers are usually at like a specific frequency. So you might be able to do, if you had like enough forewarning, you could probably figure out something to like disrupt a laser. Asteroids, if you have enough warning also, so like we have, like NASA has a thing where we monitor like for Earth intersecting orbits, and you can like just push them away with like a rocket or something if you can catch them. But something that I have recently been thinking a lot about is like, so all this, like it's really dramatic to have like a large asteroid, but as we've been saying, like there are many more like small bodies that can still do damage, especially if you're traveling at high speed. And I think that like for something like dust type of material, you might be able to erect, like, let's say on a spaceship that is like purely for space, and like going on a space voyage, maybe you could erect some sort of like a magnetic field that would protect you to deflect those particles. But I haven't done the math for that.
Right. We have Jennifer asked, does the Death Star even have an engine? It's round.
Yeah, yes. It has an engine. What?
Yeah, well, since it's round, does it have an engine? Like, where would its engine be?
Oh, I'm gonna say middle, but I don't know for sure where they put it. But yeah, I mean, it has an engine, definitely. They shut down the power.
And then Jennifer, a different Jennifer, asks, how would the Death Star go into low power mode?
Oh, yeah. Like, let's say maybe you only turn on like one of the beams. I mean, usually you can, like, it's usually not too hard to have, like a kind of continuous thing where you can set the energy output of those beams. So presumably, when they had their meeting, their roundtable meeting of like, what all do we want to destroy with this thing? Someone was like, oh, maybe, just like a city sometimes, a planet sometimes, a moon sometimes. So they probably have all sorts of different settings, and we just didn't get to see it.
How does the tractor beam work?
Oh yeah. I have no idea how that would work. That is some fairy magic stuff that is happening. Darth Vader using the Force. I don't know. Because yeah, like magnetic field strength falls off really fast. Maybe if you have enough power to like make these planet-strong lasers, you can generate a magnetic field that would just pull anything in somehow. But even that is kind of weird because like metal doesn't like to be magnetized or anything. I don't know how you do that.
Could a single biome planet exist like we see in Star Wars from Susie?
Can a single what planet?
A single biome, which I think is
Oh,
your section, right?
I don't think that I actually have that in this one, but effectively, I'm gonna say yes. Like especially like moons, that would be like fairly easy, and especially if it's a very extreme environment. So like a all desert biome or an all tundra biome. Those are things, all ocean. Like those are things that have some solar system analogs. Like a pure forest biome, I don't totally know if that could work.
All right. Amy asks, I heard that you can collect micrometeorites on your roof. Is that true? And I can take this one.
Yeah.
Yes, you can. There's a great book from John Larson that you can go read. And then also we do have an episode of They Came from Outer Space with Craig Whitford that you can go watch. So there is a way to collect micrometeorites. Generally getting stuff from your downspouts and your gutters is a good way to do it. And then Ronnie asked, will you be able to see a meteor shower tonight?
Tonight? I don't know. Can you, Shannon?
Yes, there is a peak tonight of the Eta Aquariids.
Oh,
It
cool.
probably won't be very easy to see tonight because we do have quite a full moon, but there is a peak tonight for the Eta Aquariids. So go outside and see if you can see some meteors tonight. If it's clear.
Around what time? But you don't have to look it up. Presumably you have it somewhere.
Just go outside tonight. I'm looking the zenith hourly rate, which is like how many you see, is only 40, and that's like how many you would see per hour under the most ideal conditions if they were coming right at you from zenith, which is not what's going to happen. So you'll at best see like a couple per hour, but it's worth it. Like if it's not too cold and it's clear, I mean, go outside and see what you can find. It's always nice, and it's always nice to try to find a shooting star, a meteor coming through. So why not? You don't have to get up early in the morning. And if you do get up early in the morning, you've got a nice view of some planets in the east before the sun rises. You got Jupiter, Saturn, and Mars. Okay, I'm done now.
Okay. Well, I don't know. So we want to end by 8, right? Or
yeah, it's about 8 now, but how long's your last section?
I think it's about as long as the last one, so I think it's a bit too long. I'll race through it really fast.
Okay.
So I just want to point out, so Tatooine, there's this really iconic shot, and you can work out, so that means it's in a binary solar system that has the 2 suns, right? So there are a couple ways that you can get 2 suns in the universe. And we can figure out basically which type of them Tatooine is. And because we have this episode 1 data where they look the same, we can basically say that Tatooine is an Earth that is orbiting 2 binaries. So it goes around both of them. And this is something that Kepler actually found. So it's this planet called Kepler 16b, and all the astronomers call it Tatooine. So we were able to reconstruct its orbit even and the properties of its stars. So that was pretty cool. And they made a poster about it. So you can go buy this poster if you want to. And then I had this little thing about like life on moons. So it's really cool in Star Wars. They talk about moons all the time. They're like always going to moons, which is interesting because a lot of sci-fi focuses on planets, but actually most of the probable worlds to have life in our solar system would be moons. And there's a whole categorization system for like the likelihood of being able to host life, and Enceladus and Europa are like some of the highest candidates. So these are actually like regulated, where we have to be really careful about like sending probes, because if life is developing, we kind of like prime directive it, and we don't really want to be like interrupting that development. So it's just the super speedy version of the last part. So I want to share this video that I really love as my May the 4th gift.
I'm sure Luke wasn't on that thing when it blew.
He wasn't. I could feel it.
You love him. Don't you?
Yes.
All right. I understand. Fine. When he comes back, I won't get in the way.
It's not like that at all. He's my brother.
All right, that's it. That's all I have.
You got a couple more questions. Do you want to take them?
Okay, unless they're about asteroids and meteorites, in which case you should answer them.
Okay. No, I'm watching the reactions now to this. You're getting lots of laughs. All right. So, what would happen if a ship had no engine from Megan?
Depends on how fast it's currently going. Object in motion tends to stay in motion. Like, what's going to happen to it? I don't know. Like, this is you need to just go listen to Space Oddity by David Bowie. Like, that's what happens.
All right. And then with the gravity being what it is on Tatooine, would the jets on the speeders have to be at a different angle to adjust for the different gravitational pull?
I don't know. From Luke walking, it seems like Tatooine has Earth's gravity. So, gonna say no.
Okay. All right. Otherwise, it's a bunch of LOLs for the
I'm
video.
glad you guys like the video.
Yeah.
I love it so much. I've watched it like 20 times and it still cracks me up. So,
All right. Well, I think that is our Science of Star Wars. May the 4th be with you. If you guys have more questions, you can go ahead and put them in the comments and we will answer them via the comment section. And you stop sharing your screen.
was I not supposed to? Sorry.
Okay, you're fine. I was just got confused for a second. Thank you guys so much for joining us, and stay safe out there, and we miss you all at the planetarium. And if you would like to consider donating to the planetarium at all during this time, we would appreciate it, and I will put a link in the comments as well. But otherwise, thanks so much, and go watch Star Wars if you have not done so yet today, and enjoy that, and go watch all of them. Why not? Go watch them in whichever order you prefer. There's a lot of different orders you can choose to watch them in. I know that we have an order. We discussed this, my husband and I, before we had children, which order to watch them in with them. Very important. So anyway, thank you very much, and go have a great night. And thank you, Dr. Chelsea Harris, for taking us on a wonderful journey as well. So round of applause. All right. Thank you.